Hello everyone, today I will be going over problem 1598, the crawling log folder problem, which is classified as an easy problem in Leetcode. In this problem we have a file system log that keeps track of some change folder operations. The three operations that it keeps track of are ... which means that you move to a parent folder of the current folder, in the ... which means you don't do anything, you remain in the same folder where you're located, and some X letter followed by a slash, which means you move to a subfolder, and that subfolder is guaranteed to always exist. So before we go ahead and implement the solution for this problem, we need to think of some data structures that we can utilize to resolve it. So some data structures that we can use are an array list, where we can keep track of the folders as we come across them in the log and remove them as we move up to their parent folders, and then we can return the size. Another data structure that we can use is a deck, which is a double-ended queue, and then again we add the values as we come across them and then pull them out from the tail as we move up to the parent folder. And now just by looking at this picture, we can see that the most ideal data structure for this solution will be a stack, because it works just like I explained the deck. And so, for example, in the first example, we have, for example, D1, and then you will add a D2, and then when you come across the ... then you can pop this value, and then you add the D21, which is going to be a subfolder of D1, and then when you have the ... which is the last operation in that sample, then you remain there, and then you can just return the size of the stack, which is 2. And that's basically the number of operations that you would need in order to go back to the main folder. So we can go ahead and implement that solution. So the first thing we're going to do here is declare a stack. And this stack is going to hold a string values. So we're going to be saving the folder names. I'll just name a stack equals new stack. Now to iterate through the logs, we're just going to use a for loop, and we're going to say string operation from the logs. And inside here, then we can utilize a switch statement on the operation value. And we can say, well, for the case where we have a ... that means that we are going to go up to the parent of the current folder. So that means we're going to do a pop, as I explained in the drawing. However, we gotta remember that this case right here is saying that if you're already in the main folder, you must remain in the same folder. So what they're saying is that a ... could be the first operation in the logs, even though we're currently in the main folder. So to check that, we can just verify if the stack is empty. And if it is empty, you can just break. Otherwise, you can pop the top value and then break. Now for the case where you have a ... well, in this case you don't do anything, so you can just break. Now if you have anything else, that means it's going to be some random letter followed by a slash, so we're just actually going to name it default. Then you're going to push it into the stack, so you can say stack.push operation, and you're going to break. And then finally, here we're going to return the stack that size. So if we run that code, we can see that it passes the sample test cases. And if we submit it, we can see that it takes about 2 milliseconds of runtime. Now, if we look at this code, we can see that we're actually not using the contents that are being stored inside the stack. The problem is not asking us for the folder names or keeping track of the folder names. They're just asking us how many operations are needed to go back to the main folder. So we can make this application use less space, because we are currently building a stack. The space complexity of this problem is big O of n, and we can reduce that to big O of 1 by, instead of using a stack, we can just say if we have a integer called depth. Now we're gonna reuse the for loop, but instead of doing a pop, we can say depth minus minus, and instead of doing a push, we can say depth plus plus, and over here in this if statement, we're gonna say if depth equals 0, then we're gonna break. So by utilizing this depth, we're doing the same, essentially the same thing that the stack was doing, keeping track of how deep into the folders we are. And here in the return, we're gonna just return the depth. So now if we run this code, we see that it passes the sample test cases again, and we submit it. Actually, it runs a little bit faster in the platform, although the time complexity is the same, which is big O of n. Okay, so that's it for today. Thank you for watching.